Chapter 9, Thermochemistry, Exercise 9.43. Suppose that 26 grams of each substance is initially at 29.0 degrees Celsius. What is the final temperature of each substance upon absorbing 2.25 kilojoules of heat? This is 2,250 joules. Part A, we have gold with a specific heat capacity of 0.128 joule per gram degree Celsius. Now we'll just use this equation. Q is equal to mass times Cs, the specific heat capacity times delta T. Over here I'm going to use T final minus T initial here, and that's the equation we're going to use. And in this part A, we have specific heat 0.128. I can't type the unit in this equation, so I need to make sure joule, grams, and degrees Celsius are used in other places. The amount of heat, it's 2.25 kilojoule. So I need to convert it to joule. We have the mass. Mass is 26. Mass is 26 in grams. We don't have T final. We have T initial, which is 29.0. I'm going to use 29 here because anyway, in the end, we just need to know the value of the final temperature. All right. The reason we need to keep two sig figures is because of this number 26. There are only two sig figures here, and if you're familiar with the rules of keeping sig figures, this T sub f should contain two sig figures as well. Alright, this is the equation we need to solve. T sub f is our variable. Alright, so what I will do is I will do this. I will do T sub f minus 29 is going to be 2250 divided by 26, and then divided by 0.128. So I'm going to put this equation here so you can see how I manipulate everything. I'll put an equal sign here, and it should be divided by, I'm going to use divided by, I'll put this here on the bottom. Alright, so this is the equation. And of course, if T final minus 29, this is the temperature change, is equal to this, then T sub f should be 29 plus this. Alright, so I will just do this whole thing plus 29. That will be our T final. Alright, so this is the equation we're going to use. You can see a warning sign here. This calculator does not support this type of equation. Well, we can just delete this part. We'll just do the numerical calculation over here. This is going to be 705. However, it contains three sig figures. If you enter 305, what I will do is I will enter 3.1 times 10 to the power of 2. Oh, I'm sorry, 7.1 times 10 to the power of 2. Alright, I just rounded this 5 up. Okay, so mastering chemistry, calculated delta T first, heat divided by mass, and specific heat capacity. So the temperature change is 680 degrees Celsius, and delta T is T final minus T initial. Therefore, T final is delta T plus T initial. Pretty much the same calculations here. T initial plus delta T here, and we get 710. Alright, again we use this equation. Part B, silver. So this is silver. Silver has a larger specific heat capacity. We'll just use the same equation here. We'll replace this specific heat capacity. We get 397. We round it to 4.0 times 10 to the power of 2 to keep two sig figures. Submit. You can see the temperature change is smaller for silver. Alright, this is the temperature change. It's smaller because silver has a larger specific heat capacity. This is aluminum, 0.903. Same equation. We'll get this number. We round it to 1.2 times 10 to the power of 2. Part D, this is water, I believe, 4.18 joule per gram per degree Celsius. Water has a very large specific heat capacity. That means it's very hard to change the temperature of water, and that's why the oceans can keep a roughly constant temperature during day and night. Alright, and you can see the temperature change is going to be smaller for water. I will replace this number with 4.18, and you can see this specific heat capacity appears on the bottom. That means this delta T will be smaller. Alright, and the final temperature is only 50. Over here I just use 50, and I place a decimal point here to emphasize there are two sig figures. Alright, so delta T is only 21 here. Why it's only 21? Because of this very large specific heat capacity. Remember, for gold it's only around 0.2. For silver also around 0.2. Alright, so this is at least 10 or 20 times larger than the specific heat capacity of silver or gold. So over here you can see this delta T is much smaller. It's only 21 degrees Celsius for water, and if you record the number for gold, I think delta T for gold was 680 degrees Celsius. Alright, that's much larger than this.